I'm Tony Alves. I'm the Director of Product Management at Aries. I'm responsible for the design and development of the online submission and peer review tracking system and the production tracking system, editorial manager and production manager. I've been with Aries almost 18 years, and many of you know that we were recently acquired by Elsevier, so just putting my disclosures out there. Today I want to talk to you about Manuscript Exchange Common Approach, also what we're calling MECA, and it's a protocol for transferring submissions between systems. So authors experience a loss of time and effort with their manuscripts when they get rejected, and then they have to go and resubmit their manuscript at another journal. So repeating this submission process is tedious, it's frustrating, and it's also estimated that about 15 million hours of researcher time each year is spent on redundant reviews and unnecessary reviews. Also, with the growth of cascading workflows, it means that more transfers are happening between publishers within a publisher's group. And often, those publishers are using different submission systems based on a journal or editor preference. In addition, the popularity of preprint servers means that there are more papers coming from preprint servers and also moving from preprint servers or from journals to preprint servers and from preprint servers into journals. So these frustrations have been addressed by vendors like Aries and other systems in various non-compatible ways, which has resulted in inefficiencies and wasteful resource. And if only the scholarly publishing industry could get a group of competitors to collaborate. So, really spearheaded by John Sack of Highwire, Aries Systems has been working with Clarivate, with eJournal Press, with Highwire, and with the Public Library of Science for almost 2 years to put together a way to move manuscripts around the scholarly publishing ecosystem. We have developed a common approach that anyone can implement to transfer manuscripts from system to system. It's not a clearinghouse, it's not a database, it's not software, we're not developing software. What we're doing is defining a protocol that anyone can use for free. We are currently working with the National Information Standards Organization, NISO, a U.S. nonprofit that develops and maintains technical best practices related to publishing to make MECA a, quote, recommended practice. So we began our initial discussions by laying out several principles to help guide us. We understood that it's really up to journals and authors to decide what information should be transferred out of a journal and what information should be transferred into a journal. So the control of the data is with the journals themselves. So what we had to do is we had to agree on a minimal amount of data that was needed to create a submission in each other's systems. So this minimal viable product approach allowed our organizations to get the development scheduled really quickly, and we focused on the lowest common denominator technologies like FTP and on industry standards like JATS in order to minimize the barrier to entry. Again, please understand that we're not developing code. There is no central repository of the submissions, and there's no ongoing tracking system that monitors manuscripts. This is a recommended practice that any system should be able to put into place. So MECA is focused on 4 use cases. The journal to journal, which is the core use case for transferring manuscripts between journals using the different submission systems. Preprint servers to journal and vice versa for manuscripts that have been posted on a preprint server and the author wants to submit the paper to a journal, or it's been submitted to a journal, and increasingly journals are sending those papers off to preprint servers. Similarly, for authors, using manuscript preparation tools like Authorea and Overleaf, Mecha can be used to transfer papers from those types of authoring services to a journal. And other secondary use cases include transferring submissions to and from production systems such as comp systems, publishing platforms, and institutional repositories. So let's take a closer look at the different project areas that make up Mecha. The first challenge was to make sure that we're all using the same terms and that those terms mean the same things. So we defined our terms, identifying like terms so that we were all speaking the same language. This is currently a living document that is being revised and added to throughout the NISO working group process. Another project area was packaging. That's how the files are assembled and sent. So inside the package are 4 XML files, plus the submission source files like the manuscript, figures, tables, etc. And we're going to look at each of these components next. So the goal is to be able to pass file information from system to system. Manifest information defines what is in the package and how it's structured. So we developed a manifest XML, which identifies each file in the package, and it's up to the receiving system to decide what to do with each item when it's received. So here is an example of the manifest DTD from the original iteration of Mecha. This is likely to change as the NISO working group refines the process. And also here's a manifest XML, which is also subject to change. And that's just to show you that we are doing some of the hard work. Transfer information. So we have defined what the transfer package looks like, and now we need a way to let a receiving system know who is sending the data and files along with contact information in case of errors. So we developed this transfer XML DTD to handle all of this information, and it also identifies what the submission is and includes security information and processing instructions. So again, a transfer DTD with information about who is sending it, who is receiving it, and other processing data. And then, of course, there was also XML that we've developed. Another project area is submission metadata. So the submission metadata is tagged in the article.xml file. That must conform to the JATS Green DTD, also known as Journal Archiving and Interchange tag set. Green is the most permissive and flexible of the JATS models. The metadata is listed here. You'll notice that there's a minimal set of required data, which is really just the article title and the corresponding author. The sending system can choose to send more data, and the receiving system can choose to accept more data, but those are decisions left up to the submission system. Remember that we're just focused on being sure that the submission record can be created. That's really the most important thing, is that a submission record can be created when it gets to its destination. If the receiving system requires additional data to process the paper, then the data, and that data wasn't delivered by the sender, then the data would have to get into the system in another way. So, like for example, in Editorial Manager, a paper that is transferred into EM with minimal data sits in what's called a transfer folder until editorial staff come in and either provide the additional data needed to process the paper, or the author is asked to come in and provide the additional data, and then the paper can be processed. So here's an example of submission metadata DTD in the JATS Green format, and also the XML in JATS format. So far we've talked about how a manuscript is packaged up in a zip file, what's in that zip file, which is the source files and the article XML. What we realize is that we need to be able to transfer peer review information from one system to another. This has become a requirement, especially for some of our customers who use multiple submission systems in a cascading workflow. Review data is not appropriate for the article XML because there are no appropriate JATS tags yet for peer review content. So we developed 16 tags, a DTD, and a schema for the peer review data. Laura Randall from the National Institutes of Health and the National Library of Medicine in the US has been really helpful in helping us revise the original proposed DTD and XML, pointing out tags and data formats that contradict with or conflict with existing JATS protocols, and she's involved in this project. This is an area where I expect to see a lot of discussion and possibly major changes. This is because there is a growing interest throughout academic publishing to share and publish peer review data, including name in review content. That we're expecting to see some significant changes, particularly within JATS. We also accommodate files in the, as part of review data and marked up manuscripts as part of the package. And just to show you that we've done some real-world modeling of the peer review schema. That was particularly important so that we could understand how to handle different review elements like review questions and different scoring schemes. So identity. We realized that we needed a way to uniquely identify the manuscript, especially if it travels through multiple systems. However, we didn't want to replace any other identifiers like manuscript numbers or DOIs, since those all have specific uses and many times they contain society or publisher or journal-specific identities. So we have proposed using a universally unique identifier, though which type of UUID is still up for discussion, and that's something that we're working on in the NISO working group. Now that we have the article file, the peer review file, and the transmission information with the that's uniquely identified in a zip package, we needed to figure out how we were going to transfer that package from system to system. And at this point, we chose FTP, since all vendors know how to use it in a reliable fashion. This process is simple, it's minimal best practice, so that we can accommodate as many organizations as possible. However, there will likely be future use cases where we need a more interactive transfer. And so in the future, we're looking at defining an API that's more real-time, and we'll be examining various use cases that develop as the protocol gets implemented and we see how MECA needs to be enhanced in the future. So I've presented the why and the how for manuscript exchange common approach, and you can see from my timeline here that we have come pretty far in moving this proposed protocol from an idea to an established, officially recommended practice. Currently, Aries, with editorial manager and production manager, and Highwire's bench press, eJournal Press's EJP system, we've all implemented MECA. We have some form of MECA implemented in our systems. Cold Spring Harbor's bioarchive and medRxiv are actively implementing MECA. And the NISO working group, made up of 21 people from 15 different organizations, and you can see them listed there, will be finalizing the MECA protocols, and we hope to publish the standard by mid-2019. So for more information, you can go to the Manuscript Exchange Common Approach website or the NISO website, and you can sign up for implementation documentation once it's finalized. And that's what I have.